if you couldn't tell, we are now in the panel. All right, we did it. Cool. So I'm going to start off by asking some hopefully not too broad or vague questions to our panelists, and then at some point, you know, maybe transition to the. But I think I generally, you know, I don't want to be like that moderator where then someone's like, "Why didn't you let the people talk?" So I'm gonna have a policy like, if somehow in the course of any other conversation, don't have to wait till the audience participation part. If you have a thought or a question or something related to what's going on, I would say, you know, just raise your hand, shout it out. We are this is like a dynamic, you know, we're not an overly scripted panel. So anyway, you know, all right, let's embrace the fact that we're in the same room together. Cool. Okay, so I'm gonna start off. It's a very strange pitch, like kind of weird beating, like a semitone or something. Anyway, it's the cricket sounds to pacify us while we're sleeping. It is what it is. It makes me think. Was that the COVID alarm? Okay, well, it probably is like not inside the frequency that they can even hear on Zoom anyway. Okay, so let's start with like just since like, well, you know, we have a couple philosophers on the stage. It's not maybe the everyday occurrence at the time. I like to maybe start with you know, question maybe sort of pitched at a sort of difference of like methodological or like intellectual tradition. So here's maybe broadly a perspective on what goes on in ML, which is that in some ways, you know, maybe not to the pure mathematicians in the room, but like relative to a lot of things that happen in other areas of scholarship, in ML, there's a part of what takes place that is rather super concrete and precise. And then there's the very often like you know, an introduction that's written that sort of does the work of saying how, if at all, it relates to anything in the world that we care about, like the little part that is where the prose is carrying the arguments. That is, let's say at best, highly variable depending on who the author is, but very often kind of, you know, somewhat haphazard. And people sort of maybe like attention in a disciplinary fashion to like seeking clarity is maybe concentrated on the technical part of the paper and not on the conceptual part of the paper. And maybe one perspective on what's gone wrong in some of the interpretability world is that you have a discipline that is sort of constitutionally not in the business of honing in on fuzzy concepts. Suddenly, like that's taken center stage. It's like that's where the action is. And suddenly, like maybe we're like collectively going to pieces. And I see sort of, you know, obviously philosophy is a big tent, and there's some very technical parts of philosophy. I'd say that like philosophy broadly maybe has it's closer to the comfort zone, it seems to me, to be in the business of seeking precision and clarity, even in these, you know, broader conceptual spaces. And I guess, you know, in some sense, like it's kind of a broad question, but I guess like in some sense, like I'm curious for your perspective on like maybe whether it's like what you see going wrong on the ML side, or even just sort of maybe what lessons learned, like what lessons that like the philosophical tradition has to offer to machine learning people on how to keep these kinds of conversations on track.
I get to go first. Yeah, so I mean, I think okay. I mean, I think it's a really good and important observation that there is a tendency, and we see this with interpretability, we see it with explainability, we see it with bias and fairness, this idea that the concept becomes what we can measure and quantify, as opposed to what we can measure and quantify as an operationalization or a precisification or an approximation of the vague fuzzy concept. And so here I think there's real value, not just in say what philosophers often do, but what we see, for example, in linguistics, where there's a long tradition of taking the idea of semantics, which can be vague and qualitative in certain kinds of ways, and trying to say, here is a useful model, right? Use the old statistical thing, all models are wrong, but some are useful. And to say, we should not be trying to say what interpretability is. We should be trying to say, here are a set of operationalizations that are very useful in thinking about what an interpretation or an interpretable model is, or what an explanation might be. And so sort of never losing sight of the fact that the concept that we care about is not equal to the technical machinery that we deploy. I will say, you know, philosophers often forget that there's real value in technical machinery, right? So we also want to avoid the converse problem, which is saying, well, the technical is not identical with, it's not exactly what we had in mind, so therefore we shouldn't even bother. Right? And I think that that's where the most interesting, but also the hardest work is to sit between those two perspectives and sort of simultaneously be able to keep in one's head the value of and the use of the technical, while never, you know, essentially falling prey to the fiction that this is all there is. And I don't, you know, and that's as I actually don't think philosophers are special. We tend to, people who are philosophically trained, I would argue, often fall prey to that converse problem. But it's why the multidisciplinary work can be so powerful, because you do have these people with, you know, Sina mentioned diversity of approaches in his talk. And I think that that's really key here, is having, you know, somebody at the table who's always saying, yes, but how can we make this more precise? While someone else is saying, yes, but how do we not lose sight of the somewhat vague, perhaps slightly inchoate concept that's driving the work?
Yeah, just echoing what. Does this work, or is it too far? Yeah, just echoing what David said. I think actually maybe cognitive scientists are typically in a good situation of thinking more seriously about construct validity, or the validity of the constructs that they use. I think philosophers are, maybe what they can offer is their comfort with lack of clarity in the concepts. But I share some of David's, I think maybe this wasn't your concern, but some of the things that sometimes you can get also stuck in conceptual analysis and kind of be quite resistant to any type of operationalization at all. So this diversity of perspective is definitely important, and in many cases interpretability, but also fairness, which again we see in many cases that papers start in the name of precision. So like, this is what we mean by fairness, but it's unclear exactly whether that translates to the concerns of the kind of animates the work in the paper. So I think both fields actually can learn from each other and from empirical disciplines that are in the routine case of operationalizing thorny concepts. But keeping this distance, I think, is very important.
Thanks. So I guess one thing that maybe came up in different ways in both of your talks is something about the contingent factors that are not necessarily captured just in, say, the measurements in your data set that influence what would constitute even and let alone interpretation, even like the rough sort of form that it would even take. And so you talk about goals. Sina, you kind of talked about the system in which it's being deployed. And so there's this question like of there's this perspective of interpretation as being this very contingent, contextually driven, or certainly interpretation of being this contextually situated object. And then there's a discipline that is sort of context agnostic, which is the one of developing a sort of what is hoped to be general purpose machinery. And so I guess how, if at all, are these reconcilable? Like, is there to be general purpose machinery? Is it so limit, like, is it a fool's errand? Like, where do you sort of see, if anything, the role of a kind of general purpose interpretability discipline?
I think, of the camp of thinking that things are so goal dependent in certain cases and use dependent that trying to come up with the unified interpretability machinery for all of these different purposes and goals is a fool's errand. But I do think that in this, if we have maybe a set of constraints, a particular domain and a particular aim, and in many cases we do have this, and a particular set of limitations, we know that decision makers in this domain regularly or typically or systematically fall prey to this type of limitations, then I do think that we can choose which of those general domain machinery is actually suitable for that type of domain, that type of data set, that type of interactive setting. But whether if by that we mean that can we then subsume all of these things together slowly to make them part of the same science, I'm not very confident in that.
I think I might be a little more optimistic.
Okay.
In the sense that I'm more optimistic that we could come up with what we might think of as a general framework for interpretable machine learning that has key free parameters. And those free parameters are going to be contextual. I am really pessimistic that there's going to be a science of how to set those parameters, right? But I think that's where the art is recognizing, oh, this is the goal that we have. Here are the relevant contextual features that specify those parameters. But I have some optimism, much as we've been able to do with a lot of machine learning more generally, or AI, whatever that's supposed to mean more generally, where I think we've, I don't know, my perception is that as a community, we've largely moved away from the idea that that you don't have to talk to subject matter experts to do machine learning. I mean, I'm old enough to remember a time that people had this attitude of, well, just give me the numbers and I'll give you the truth. And there was almost this disdain, I'm thinking here in the mid 2000s, there was almost a kind of disdain by some folks about engaging with people in a particular domain. Like, why would I have to talk to those folks? Just give me the data and we're good. And then, they have to interpret the model that comes out, but why would we need to talk? That, I think, has faded a lot. I think that there's a lot more of a recognition of the importance of working with subject matter experts to understand what the data actually mean. And I think that actually gives me optimism about the ability to have methods that are in some sense, they're domain agnostic in as much as they don't make intrinsic reference to the domain, but these free parameters, the contextual variables that have to be specified, do pick out the as it were, right parts of the domain. So I don't think we can get to a world where you can just do interpretable ML and you don't have to know anything about what the numbers correspond to. That, yeah, that's a fool's errand. But the idea that interpretability could permit of precise operationalizations much as notions of, say, independence, which is actually, despite the fact that it's used all the time in statistics, is a kind of vague, fuzzy notion. This idea of two variables being independent of each other. There's a qualitative sense that is approximately operationalized by statistical tests, whatever your preferred method is. I'm optimistic that we might be able to do something similar for interpretability. It's not going to be a automate it, press the button and walk away. The human always is going to have to be playing a critical role. But I see Shai is wants to jump in.
Yeah, I mean, I'm kind of implicitly you seem to imply that there is this set of parameters which are generic, and now the specific domains will just require setting the values of those parameters. And I'm skeptical about the existence of a generic set of parameters that will be useful for a big variety of domains. So maybe if you could give an example of such parameters that you have in mind, or you know, relate to this question of, do you think there really exists a generic overreaching parameters that now it's just a matter of setting them up?
So, I mean, there's a level of abstraction where I think the answer is probably yes. That doesn't mean it's a useful level of abstraction. And if the free parameter is a set of loss functions from which one can select, that's not a terribly useful general setting. But I mean, I guess I see, for example, in my own work, we've found similarities in how we approach the construction of variables in the two examples I kept referring to, climate science and neuroimaging, that actually the very same kinds of methods work at the sort of schema level. We have to tweak the particular kinds of loss functions. We have to bring certain kinds of domain knowledge in the sense of, you know, these factors can't be related to each other, right? We have certain kinds of background knowledge that we can bring as prior background. So that makes me optimistic that we can at least, that we don't have to do a sort of bespoke one-off solution for every new problem. Now, there's a giant middle ground between everything's a one-off and the one true, entirely encodable in a supercomputer system. That's my optimism, is that maybe we're a little bit more over here than over here, but that's an empirical question. We just have to see, and it may very well differ depending on the scientific domain that we're operating in.
Yeah, I kind of agree with David on there's a hope that we can find high-level principles or schema to unify things, but it's kind of, I would see it as an evolution that we're going to learn new things and we might refine it and we might decide some of the principles we hold dear might not apply anymore. And to bring up another point is I want to hear from both of you. How do you think, I haven't heard as a high-level mention of empirical evidence. For me, somehow, both in machine learning, we don't talk enough about empirical evidence to back up the whatever interpretability we might be discussing, or philosophically, you know, we have two here. How much value the modern philosophy put on like survey empirical evidence or forming concepts rooted in empirical evidence? I feel like there's a lack of reality. We talk to experts, they're not exactly reality either, right? There's something a lot more objective beyond the experts. So that's one thing. The other thing, maybe later, Sina, to continue the discussion we had earlier, is I'm kind of have the philosophy of human has to be in charge. So it's a bit disturbing that you think that the machine should be in charge at the system level. So maybe to hear about later, yeah. First,
do you want to talk about
evidence.
empirical evidence?
Yeah, I mean, so there's, I mean, I think there's a couple of things tied up in that first question about empirical evidence. So one is, there is a pretty rapidly growing community of people trying to look at, you know, what model classes actually are interpretable. Well, in the sense of interpretability means that if I show this to, you know, an individual from this group, then they will have the following kinds of cognitive performance and cognitive capabilities after interacting with the model. And you do get, some of those were the kinds of papers that Sina was noting. You get some weird results. So people sometimes trust this partially motivated a bit of the question I asked Sina. People actually will sometimes trust black box models more than interpretable models. So we have empirical data showing that if you give people an interpretable model, they like it less than if you told them nothing at all. I mean, like it's a
simple decision tree.
Yeah,
versus...
it's a 2 or 3 level decision tree versus you tell them it's a horribly complicated deep neural net and they go, yay, I like this. Now that's one particular. What people? Yeah, so it is. So that's exactly where I was trying to get to, and where I actually have some concern. This is the negative side, the part that makes me worry about having the ability to figure out sort of very general empirical evidence for something being interpretable is exactly, let's just think about all of the choices that go into running one particular study with one particular finding. We had to say, here's what we mean by interpretability. It will have the following cognitive impacts. Here's how we're going to operationally measure those. Here's the population in which we're going to test them. Here are the particular models that we're going to compare. Maybe if we'd used a linear model instead of a shallow decision tree, that one would have given a different reaction. And now we're into the world, which in cognitive science is the kind of frustration, which is there's always yet another experiment. And what I think we are lacking right now, and I think this is what your question was really getting at, we are lacking a way to avoid falling into the combinatoric mess that is just running yet another experiment. And what in cognitive science saves us from yet another experiment? Well, by and large, theory, and often computationally precise theory. And so now we're back to the very first question that Zach was starting us with, which is, how do we have precise enough theory about what interpretability means and what its implications should be, what impacts it should have, without losing sight of the fact that it isn't equal to this operationalization. Now, you asked about surveys. There are plenty of philosophers who are starting to do empirical work, basically surveying people about what their concepts are. I think most of that is not very useful because I think for the most part, people are pretty bad. The kinds of concepts that we want to get insight into how humans think about them tend to be the ones that we don't have a whole lot of introspective access to. So I, for example, don't think that asking people, what do you think causation means, works very well. You can ask people to describe or assess particular situations. You can ask them to exhibit behaviors, but asking them to introspect on it doesn't work very well. And that's what a lot of the philosophical, so-called sort of experimental philosophy work is in that vein. So I do think that this is a place where we need better theory. We need constraints about what we're looking for in the empirical evidence. Those constraints should come from a mix of philosophy, psychology, machine learning. And it's an open challenge. I mean, I wish I could give a nice, clean answer, but the reality, I think, right now is your instinct to look for the empirical evidence is right. It's not there to the extent it needs to be. And part of the challenge is that we're sort of still in almost a kind of behaviorist world of just kind of running yet another experiment to see what are the patterns we're even seeing. And I think it's more likely to be successful if we start with a bit more theory, grounded, especially in the space of explanations, grounded in what we know from a few centuries of work on philosophical work on the nature of explanation, what it ought to be a good explanation. I think we could really benefit from more of that kind of guidance.
Well, I'm just going to ask one. And
yeah, also, I just wanted to echo that point that I think you raised, the with whom, right? Which makes as your point of users and the population on which this is supposed to be important, very important, right? We have the same type of thing in neuroscience, the allure of neuroscientific explanations that mean nothing and are taken to be good explanations by kind of lay people, but any expert would think that this is pretty bad explanation. So kind of different category of people. But also, I should say that I really like this point about the need for having increased theory instead of relying on people's survey responses. I think this is another thing that we see in cognitive science a lot, in people's causal judgment and counterfactual judgments, when they have to rate which counterfactual judgment do you think is more probable. Typically, that I think, at least I think you have written on causal judgment part, I've written on counterfactual judgment part, but many of the models that try to explain people's behavior in that way are actually not very successful, trying to figure out, like, why is it that actual causal judgments are this way? Until we go, at least at a more functional level, decide what is it that we want this to do for us, and are those judgments in line with that? So this idea that we need theory to kind of put some type of constraint on what it is that we want to do, I think is also borne out in different domains that people, actually similar, like causal, counterfactual, similar to people's intuitions on explanations. I think here too, asking what is it that we want exactly this explanation to do is going to be very useful.
Well, so I wanted to get to one question and then I'll get to back to the audience. One thing that this came up when we were pretending to be unrehearsed, so we really had a lengthy email thread of at least 2 emails, and well, and this is, I think, is like a broader, like a common recurring question is there's this sort of what actually is the object where, you know, to which the explanation or interpretation pertains, and is it that we are describing some underlying phenomenon in the world, or is this you're explaining the model? And there's a couple parts here. One is that you know, there's a sort of slippage of aims of its, I mean, let alone what it would mean to explain the phenomenon or explain the world. There's a way in which it's unclear and often slipping even within the very same paper from section to section, or from the introduction to what they actually do. And there's also maybe a way in which sometimes there's like an element of hiding the ball. So like someone says, no, we're just explaining the model. It's like, why are you explaining the model? So we can make better decisions. And you say, well, what now there has to be something tethering now. Insofar as the things explaining the model, there's a belief that this explanation of the model enables you to make a better decision in the real world. There's some tie back to ultimately at the end of the day, something, you know, so I guess the high level question is sort of, do you believe this distinction? Do you buy it? If you do buy it, are these fundamentally different problems from each other, and should they be lumped together? Should they be split apart entirely? And if you know, or maybe if you don't buy it, maybe make an argument for why you don't buy it.
So I do buy that. So you mean that understanding the model versus understanding the world at a basic level?
At a basic level.
Yeah, yes, of course, I do buy the difference. I think there's a big difference. The model, among other things, may rely on properties and relations that are not really there in the world. But I think so. I think that it's kind of actually easy in a way to say that it's a mistake to say that I'm giving counterfactual explanation and then switching back and forth as if your counterfactual explanation is about the world versus about the model, because these two things are not the same. Something could have been different in the model world, but not in the world world, right? But I think there's actually kind of a challenge in terms of completely separating them when we think about some of the use cases, right? So in some of these cases, when you think, I would want to have a counterfactual explanation for recourse, right? I want to give it to someone so that in the future, maybe they can change their behavior and they get it. Now, on the one hand, we have to know how that change of behavior will have impacts in the world. On the other hand, we have to know how that changes the situation in the model. They come apart clearly, but we want it to be connected too. So if I say that, oh, you change your behavior this way, the model will make a different prediction about you, but they go in the world, they change their behavior, and then they're through some other causal pathway, they change some other things that actually the model will not make a different decision about them. I don't know if it's clear, right?
Right.
Because the model is depending on some other thing. So I think they're obviously different, but
Right.
There's
Or I
a-
think one way that I think about it in that particular example is you say, okay, well, I'm just providing a counter here. This is a different input that would elicit a different prediction. And this is actionable insofar as it provides you with some ability to impact your own outcomes. And then the slippage is that if all we were doing was training a predictive model in a way that wasn't tied to in any way to causal structure in the real world, then this is sort of like an incoherent practice, because if you're, if you're out there giving, say, this kind of like remedy, then it's like it sort of invalidates the model in the first place, unless you were in the business in the very first place of developing a model that was somehow accounting for, say, the mechanisms of strategic
exactly.
behavior or something like this. So it's like, right, I guess what I haven't seen is like a pure example where really the whole story hangs together, unless we circle back and realize that in the first place, we really need to be actually having like a model of mechanism in the world.
So let me distinguish two different issues that I think might be getting blurred together here, right? So the first is, sure, you go, I mean, just here's a really simplistic picture of what we're all doing. There's the world, which generates data, which leads to a model. And when we think about interpretability, we sometimes think about the fact that the data is not the same as the model. We do sometimes distinguish between, say, interpretable data and interpretable model. Or if you think about, folks like the kind of ML that I do, which is causal discovery algorithms, where we are explicitly trying to say we're not trying to learn a model of the data, we want to learn a model of the kinds of things that could have produced data like these. We do that. On the ML side, we do some, I mean, there is some work on, if you know that there's a selection bias in your data generation process, how do you compensate for that? I don't think we have that on the interpretability side. I don't think we have methods, in essence, to say, if I imagine just, contrary to fact, imagine I knew all of the measurement and selection biases going from the world to my data. And I can choose whatever method I want to go from the data to the model. Could I then somehow link together interpretability of the model and interpretability of the world? I mean, they obviously, as Sina said, they obviously come apart. I can have a model that's perfectly interpretable that is a model of a world that is incomprehensible to me. We might think that, an economic model is interpretable, but I can't understand the quantum mechanical model or quantum mechanical reality that underlies economics or something, I don't know, like that. So I do think there's actually a really potentially interesting empirical question, which is, could you, if you knew something about the measurement setup, if you knew something about the biases of various sorts that go from the world to the data, could you actually sort of reverse engineer those to get from interpretable model of the interpretable world? Like, could we start to link these together? And I don't know that we know, I mean, that's just an open technical question. I have no idea how one would go about doing that, but it's at least, it seems to me, an interesting one to ask. So that's issue one. A second issue, I think, is the one that you were bringing up there, Zach, which is, there's also the challenge that if I use a model to make decisions, I'm now acting on the world, potentially. And so there's also the problem that the very act of using an interpretable model is going to impact the kind of world that I'm now measuring in the next round of data collection. And in fact, you could imagine that I could use a model that makes the world less interpretable. Or, in fact, more commonly, the use of models makes the world more interpretable. And that kind of dynamic, I don't think we've got a good handle on. Certainly in social phenomena, if you start to use models, start to use algorithms to govern the allocation of resources, for example, people will adapt their behavior to make sure they get access to it. That is, people will regularize their own behavior. And that feedback loop means that the very use of an interpretable model can lead to social structures that are more interpretable. Because we humans will adapt, we're responsive to incentives, we will adapt our behavior to conform to what the model expects, and thereby regularize our own behavior and make it more interpretable. Right? So there's a whole other set of, I think, really interesting feedback loops, especially with social systems, that is about the dynamics of deploying a model. But I think that's also separate from this question of the distinction between the interpretability of the model and the interpretability of the world.
I'm tempted to go on a tangent about looping effects of humankind,
Exactly,
but I have a different feedback loop. Which is, oh, cool. So I'll go to Giles. Is it a soft G? Did I mess that up? All right, great. Thank you.
And well, I'll rely on you to repeat the question, or I can get a microphone. I don't know if it occurred out there in Zoom land, but at the start of the panel, there was a joke about having a couple of philosophers on stage. So we'd start with Plato. And I therefore want to ask about dialogue. But more specifically, I think in both of your talks, there was this underlying structure of saying, well, there may be different ways of looking at this problem, either from two different criteria for the way you want to structure a model that you can understand, or from a human versus a machine. And both of them really require an interaction. In fact, the question for David from Joe Halpern here was, well, okay, if we have these two models, surely there's a lattice and an intersection or a union of these concepts that we can base this on. And if I think of decision support in machine learning, I really think of that as being something along the lines of, I want a dialogue between this machine learning algorithm and whoever is ultimately making the decision, not so much on the which one of these people do I trust, but in terms of the human decision maker saying, is that a decision from the machine learner that I actually trust? And so there's a question of, are we thinking about interpretability in far too much, or explanations in a far too static sense, as opposed to being some form of more interactive model, and in which case, we're all kind of doing this wrong. Not everybody, I've seen a little bit, but but is there and this is a kind of fuzzy question, but we've got philosophers on stage, so is there a way in which we should be focusing differently?
Yes. No, so to elaborate a bit, I mean, yes, I think if we think about, let's take explanation. I know this is interpretable. Let me just focus on explanation for the moment. If we think about explanations, if Sina says to me, or if my daughter says to me, why did something happen? And I give her an explanation, if she's unhappy about that, she can ask a follow-up question. And so now which follow-up question she would ask is going to depend on why she wants the explanation, for example. I might be able to do a good job of anticipating why she's asking me for this why question, in which case I might be able to give something satisfactory at the outset. But it is important in terms of the social interactions and in terms of the intellectual dynamics of the person receiving the explanation, or the person who's receiving the model. It is important that they can ask follow-up questions. I think that that's absolutely right. Now, when I think about what we're all engaged in, I think where I would maybe push back a little is I think that, and the reason I mentioned the being able to anticipate what the explanation requester really cares about is, if you design, develop, deploy your system appropriately, you may well be able to ascertain that in a way that you don't have to provide real-time dynamic and interactive capacities. Now, that involves co-designing with the people who are going to be interacting with your system, co-developing with them, co-evaluating with them. It's not something that I can, just sort of sit in my philosopher's armchair and say, oh, here's what people clearly want. That's, the way that we end up with a whole lot of systems that don't serve the needs of the users, right? So there does, I think, need to be interaction in the development of these systems. I don't know that it needs to happen real time post-deployment. It might need to. There will be contexts where it would need to. But I do think there are other ways of interaction needs to occur at some point. It doesn't necessarily have to be only at the end, though. You might be able to have a system that does not have interactive components because you did all that legwork at the beginning. But it is, and that kind of legwork, I think there are a lot more people who are doing that kind of co-design. Still not nearly enough, but more.
Did I ask for the online people?
Yeah.
Oh, do you want to answer that? Go ahead.
No, I mean, we can talk.
Okay, so here's a question from Ruth. And she's asking, following up on David's contrasting between philosophers focusing on abstract concepts and accepting them not being precisely defined, and computer scientists focusing on technical solutions and potentially confusing them for the concepts of themselves. Is there a more abstract way of developing criteria for whether a technique is useful towards the abstract concept? And Deirdre has a comment, which we can get back to. So you guys want to comment on that?
So the question is, are there ways to know which direction one should be trying to move, or?
The question is there a more abstract way of developing criteria for whether a technique is useful towards the abstract concept? So coming from technical towards the abstract concept is how I read it.
I mean, one part is exactly the kind of co-design, we were just, actually figuring out whether something is useful for particular groups in particular uses. I think there's a certain amount of importance in always I'm trying not to just be a philosopher and say, you always have to go back up to that level. So there's always value, I think, in doing that. The key is to do it dynamically. So if you think of it in a sort of very simplistic way, is there's the sort of qualitative, vague, conceptual level, and there's the precise technical level. Sort of being able to oscillate back and forth in terms of which you hold fixed and which you're working on, I think is really critical, because there are times that technical work has revealed really important conceptual differences that had been lost or had been blurred or elided in the philosophical work. And then we realize, oh, wait, this is actually a really important distinction. A classic one would be the distinction between evidential and causal decision theory, which sort of reshapes a lot of the philosophical debates in action theory when people go, oh, wait a second, this is actually a really important distinction. And I think that we see some similar things happening in the causation literature. It's happened, counterfactuals, right? So I think that the key is less about any particular method for moving between them and more about this sort of oscillating dynamic of which you're holding fixed at a moment.
Maybe I'll read Deirdre. So Deirdre commented on Ruth's question. She said, measurement modeling is a useful technique. See Jacobs, Abigail Z, and Hannah Wallach, Measurement and Fairness in Proceedings ACM 2021 on fairness and accountability.
Yeah, definitely.
And transparency.
So explicit modeling of what you're, I think a broader thing there is being intentional and reflective about what you're doing. Not simply going, well, this is what we do in our lab, so let's just keep doing that, which sounds really simple and banal, but is hard to do in everyday life. If you're, it's sort of like being in a startup where you've got to ship, you got to get that paper out the door. And you don't want to have the proverbial paralysis by analysis where you're spending all your time analyzing things you never actually do, but also never being blind about the choices that are being made along the way.
I think it was like the first thing I ever heard in I moved to like San Francisco from New York, and round up in like the startup world. It's like I counted the first analysis paralysis. Shivani.
So I agree that the loss function or who's using an interpretability tool might strongly dictate like how we design it. But I think one thing that I feel like it sidesteps is that in many cases, we might not have a choice. Like for a particular application, you have multiple stakeholders who have all to be involved. Like going back to Sina's example, for instance, where like the complementarity thing might require the model to be not interpretable, but like from a social justice perspective, maybe it's like it could probably be very problematic to tell one group of people we're like making your decisions based on human, and the other that we're using this uninterpretable model to make your decisions for you. And so I wonder what you think about this. And of course, there are many more stakeholders involved in like typical applications. So then is it hopeless for us to think about interpretability at all for even for a particular tool, let's say, or a particular model?
I think that's a great question. But I wouldn't say it's hopeless for a number of reasons. One is that I think in many of those cases, what we might mean by interpretability are actually kind of very different. So what let's say in the case of complementarity, I said in that case that one implication might be that in some senses for the user, if the model is not interpretable in some sense, it might be better for complementarity, but it might be interpretable in another sense from the perspective of the person who's designing this team. Namely, just like take it as a hypothetical example, what type of features does this model rely on? And is it different kind of features than humans? So this is one thing, but then there's the other thing is that I think for many of the things that, because in most of these cases, interpretability in this very variety of senses is also a means to an end. There are often other means that can get us to those ends. In many cases, so social justice, I think, is a good example. I am not convinced that model interpretability, like that is interpretability of the predictive model in itself in particular sense, is a better means than many other types of things for promoting social justice concerns. I think having regular auditing practices, having kind of access to the data, knowing co-design that has come up, knowing like if I tell somebody that this feature is very kind of important in the way that I make my decision, but they have no idea what that feature means. They have had no role in designing that feature, which is like in many cases, actually this happens. Like who's a good student? That's why you were not selected, right? So I'm a little bit more hopeful there because I think in many cases where things seem to be coming apart and like literature on complementarity, as you said, is like a great example of that. That some people say, oh, explainability approaches are actually bad for complementarity. I think it's actually different senses of interpretation are meant. There are different users for them. So if something that is bad for the user might not be bad for the person who designs it. And in certain other cases, just like we just have better aims. Social justice fairness, one example. So we can put these things that look on the face of it to be in tension with each other together. In some other cases, we don't even need some of them because we have alternative pathways of getting to what we want.
So my next question maybe brings together some notion of a few things we're talking about modeling, about mechanism, about evidence, and about complementarity. So yeah, I think a recurring theme here is very often is sort of saying, well, let's say we're in a complementary setting, we care about how well a human performs at some task. And so this could be our fitness function to guide the choice of what it is that constitutes a good explanation in this sense. So now we have some data, and we take no stand on where the data comes from, what we're trying to predict, how it's related to the task. But we just sort of say someone's got a model of something based on something else. Predict something from something. We think it's sort of like and I would say, well, if you can somehow take that model and get it to poop out an explanation, and it helps the human to do whatever's this other task, we've taken no stand on how it's related to what we were modeling. But if somehow we're able to do a good job at that, we could say it's at least in this contextual sense a good explanation. So the problem to me with a lot of this stuff is that you say then where are we searching for hypotheses? Like first of all, what convinces us in the first place that this is why would we even accept in the first place is the right data to look at, or that we should take this model and try to explain it, or that it has anything to do with the task at hand? Very often it's a bit dubious. But let's just say we even take that for granted, that somehow there's some fuzzy relationship between what the neural network is trying to do in the task. We just, we're not clarifying it. And I say, where do we search for? Like what are the candidates for what would constitute the thing we would show to the human? And what people turn to strikes me as just throwing spaghetti at the wall. So like Lime, SHAP, GradCam, class activation vectors, all of this stuff, it strikes me that there is no reason, to my knowledge, they failed every sanity check ever thrown at any of them. They failed at almost every, like the best you could say about the evidence for usefulness in any real world task is almost every test showed it wasn't useful, but some were ambivalent. And yet somehow, like this is the starting point. You see, we get to the point of, well, let's go for the empirical evidence. What do we do? Well, the starting point is, these are the candidates, Lime, SHAP, this stuff. And so we're in this weird situation, which is we've got this big data, these models, we want empirical evidence for our explanations useful, but our hypotheses for like, what is the universe of possible explanations to look at strikes me as sort of like just absolutely haphazardly chosen. Like I could have just said, look at neuron 417 from layer K. That's your explanation. And it strikes me that it would do similarly well on nearly every test that's been thrown at it to all the other nonsense that we have. So just to end it on us, I'd like a panel to be a little bit provocative, because then we got to have discussions over lunch. What guides the search for hypotheses? Like I'm willing to buy this sort of functional, like aim-based view, but then what are the candidate, interventions here? Because it strikes me that it can't be the things we're looking at now. So like, what's a better way to do it?
Well, so, I mean, the first thing to say is one of the challenges of a more functional approach from the philosophical psychological side is it doesn't tell you very much about the potential interventions to try. It tells you measures to know if you've succeeded, not necessarily the things to try. But I guess I want to push back. I mean, I don't think that these methods are complete gibberish. It's not the same as pick some random neuron in a deep net. But actually, more importantly, what I would say is that part of my reaction to it is to say, yeah, that's research. I mean, if we knew the answer, then we wouldn't be bothering to do the research. So the real issue that I have is the speed with which some of these methods have moved from a research conjecture to being implemented as this is the way we, like, let's regulate on this basis. Like that's the error, I think. It's not that we've got these different ideas and we're testing them. That's the nature of research. We don't know what the answer is. It's not like we know it and it's like I know it, I'm just keeping it from you, right? I mean, are we trying to come up with better methods? Yeah, lots of people are working on that. We want to do better. The worry, or one of the big worries I have on the ethics policy side.
It's like the scientists found the chemical, it failed the cellular studies, it failed the animal trials.
And my doctor says, here, let me prescribe it.
We did a human trial anyway, and it also failed it, and now it's standard of care.
A little, yeah. I mean, it's not, maybe there's like a small, slight signal that might be because we've done, p hacking to get there, right? And so how do we set up professional standards, standards in the industry of best practices that says you don't just use this because it's the thing that you read a paper, you saw a cool paper at NeurIPS last year, and 3 months later we're going to deploy it in production code. Right? I mean, that's I think the real sin. Not that we don't know the answers yet, but that despite not knowing the answers, these are getting picked up and adopted and having really transformative impacts on people's lives.
You can't have analysis paralysis, you gotta move fast.
Yeah, exactly.
Okay, Shai and Jordan, and then we will. We have 3 questions, 3 hands, and they all look really eager. And then we'll just try to keep them,
You get the last one.
kind of curt, and then we will eat 7-hour lunch. Okay.
So David, I completely agree with you, but I think one aspect here that we have to take into account is that the sociological aspect. I mean, the industry, the media, they are looking for positive answers. They need an answer. They are not happy with saying, we don't have an answer, we don't know. So they jump on anything that may look like an answer, and there's kind of a positive feedback loop. I mean, the person who developed this vague system is very happy that's being deployed. The person who is deploying it is very happy that there is an answer, and there is a sociological dynamics that pushes towards immature solutions and boosts them and kind of tones down negative criticism.
Yeah, I mean, I think there are a lot of people who have very strong incentives to pick something and move with it, even if it's not the right thing. I completely agree, and that leads to a whole lot of really difficult questions about regulation, policy, practice. That I do think there's that's another kind of thing I work on, and I think there's a lot of us trying to do better, but it's tough given the incentive structures that are out there.
So what I was hoping you would say in response to Zach's question, and I'm going to give you the chance to either say or reject, is that you alluded to the fact that there's like a long literature in philosophy about explanations and how they work, which maybe hasn't had so much uptake in this community. And one thing you could imagine that doing is giving us a lot of options of what kinds of things can count as explanations. I mean, it's sort of hopeful. I'm wondering if you think that literature existing in philosophy can provide useful clues as to what kinds of things to look for as explanations rather than doing the kinds of things that Zach is critiquing.
I think that
both of you, yeah.
I think that's a great point. I do want to say that I think in many cases when people say interpretability, explainability, it's unclear exactly whether we want explanation or something else about the model that we would want to know because it's useful for some. So I do want to flag like that getting too connected to the similarity in terms, explainability and explanation in philosophy might be a little bit too much because most views in philosophy right now, explanation is causal, like in the different senses. But I think there's something else that you say that I really like, which I think David also mentioned, which is, I think it's important to separate the aim, the measures of success for that aim and the current methods that we have for getting there. I think the current methods might not be very good. And I think there's another way, there's always this like backlash against interpretability as such, where because some people like think that interpretability methods are not very good, which is true in many cases, they think that like the entire aim of having a like searching for some type of interpretability, explainability is like mistaken. And I think that is also wrong-headed. It's just, so I think one broader way of putting that is maybe the connection can help clarify what it is that success would look like, for what type of aims might we want this, and what does success look like from the perspective of that aim, from this kind of functional perspective. Again, it doesn't say like what the method is, which is like the task of the research, but at least it keeps makes our movements towards whatever we want kind of more precise.
Yeah, and absolutely, we should be looking everywhere to get better ideas. I mean, not just philosophy, not just cognitive science. I mean, people who work in industrial organization work on how you design institutions, companies, organizations, so as to have clear lines of responsibility and accountability and decision-making authority. Well, that's how do I make a job? How do I make IBM interpretable? So I understand what's going on in that company. There's a completely different historical tradition of interpretability that's looking at social organizations and which social organizations can we make sense of and which ones do we look and say, this is just a mess and we're never going to be able to figure out who made the wrong decision and so who gets fired or who gets promoted, right? So in that sense, I'm a pragmatist. Anything that could help get us better models, let's look to those traditions. 100% agree.
Hi, good comment so far. I am thinking that a lot of the discussion on interpretability in ML really boils, like that we have had, really boils down to what humans understand as interpretable, what we think is what we can understand and explain to each other, what we can communicate. And I feel that this, what we can do now is a result of what we have been trained over the years in the sciences and in humanities and so on. For example, plots, images, geometric figures, first order logic, these are examples that we can explain to each other and understand, and we can, I mean, I don't know if these are constructs or maybe these are just ways of making sure that we reach a common conclusion. So are these ML tools like Lime, SHAP, and GradCam just trying to, I guess, show the characteristics of the ML model in ways that us humans can understand? Should we try to create tools that create plots and images, or should we also, think about other interpretability tools that go beyond what we can currently that we are currently trained for?
So when I teach about interpretability and explanations, one of the key distinctions I always draw is between something like, say, a post hoc clarification, Lime, call it, right, something like that, and then people talk about, well, the model itself is interpretable, like it's a simple linear model. But then I think there's actually a third class, which is I can interpret Zach's behavior without, all right, I can interpret Sina's behavior. And it's not because I have a local approximation to him. It's not because I can look inside at the neurons that generate his behavior and have, that's not an interpretable, his brain is not interpretable. It's because I have the right theory of him. Roughly speaking, a kind of, belief, desire, folk psychology, which at the level of what we're all, most human behavior, that's perfectly good.
What does Sina want?
What does Sina want? What does Sina
believe?
believe? Therefore, what is he going to intend? And what does he value to do the decision between his intentions?
It's got something to do with Liverpool.
And I don't actually need very much data about Sina to generate a very rich model, a very rich interpretation of him. That's something that's a cognitive universal to the best of our knowledge. Every normally developing human, for whatever that exactly means, develops the ability to rapidly generate interpretations and revise those interpretations of other humans, other intentional agents. So I think what you're pointing towards is, maybe what we should do is, instead of worrying about restricting the model, we should restrict the behavior. I mean, maybe we should restrict our robots to only be able to act in ways that they're interpretable as if they have beliefs and desires. Who cares how they're actually coded under the hood? But they have to exhibit behaviors that are interpretable in this way. So that's a completely different kind of approach. Roboticists tend not to be fans of people saying that kind of thing, but I think it points to this idea that we need to, I think, be more flexible about whether it's generating new methods, whether it's taking advantage of the cognitive universals, for example, visual perception and pattern finding in certain kind of visual scenes. I think this goes to the complementarity issues that Sina was raising. Human-computer interaction is exactly the kind of complementarity that Sina was talking about. And a lot of that is, how do I present information in ways that people understand it, given our particular weird biases and our weird cognitive systems. Now, the one place that I don't want to say push back, but I think I am all in on interpretation, that those are about what we humans need. In that sense, I definitely want to keep the human centered. Sometimes people will talk about, well, but how do we have AI or machine learning systems that are interpretable by other machine learning systems? And I go, I don't know how to think about that. So yeah, what counts as interpretable explanation, those are going to be distinctive to our weird cognitive architectures. But even relative to that, I think there's a lot of opportunities that we haven't been exploring yet.
Like the intentional stances, and like pretty simple to describe what all the model, like, isn't there some sense in which there's one banal like explanation of all the models that, you know, given some set of implicitly, you know, undeclared inductive biases and given some finite sample, this label is the one that seemed more likely given the input condition on the data set that you observe. And that this is all there in some sense, like this is the only aim of the model, and that everything else is sort of sort of a gross anthropomorphization of what these models are doing.
I mean, I wouldn't say it's an anthropomorphization. Also, you know, specificity matters. So, you know, am I able to make sense of the prior inductive biases, for example? I can write things down mathematically. It doesn't mean that they make sense. So, you know, that's, and whether we care is in that sense a human-centered question, but I think it's an appropriate question to ask.
Okay, I just would like to thank our panelists for speaking and stepping up and filling a little more space than we anticipated having, and for making the trek. So really great to see you all in person. You have a luxurious lunch break ahead of you, so I hope you'll all stuff yourselves.
So we're restarting at 3 p.m. Pacific time in this room. Yes? Yes, we're getting confirmation.
All right.
Okay.